Have you ever stared up at the sky and wondered, why is it blue? As a kid, you may have asked an adult, and they might have shrugged, dodged, or said, because it just is. Neil deGrasse Tyson once joked that someone told him to mind his business when he asked that question. Well, today, it is your business. Because the answer is more than just science, it's a story of light, air, and a fragile blue bubble we call home. First, let's talk about what the sky is made of. Earth's atmosphere isn't empty, it's a mixture of gases and tiny particles. About 78% of it is nitrogen, 21% oxygen, and the remaining 1% includes argon, carbon dioxide, water vapor, and trace gases. And floating through all that, particulates, things like dust, smoke, pollen, sea salt, even microscopic bits from volcanoes and pollution. These tiny things play a huge role in what we see above our heads. When sunlight reaches Earth, it looks white, but in reality, that white light is a mix of all visible colors: red, orange, yellow, green, blue, indigo, and violet. This is called the visible spectrum. You may have learned the acronym ROIBIV in school. And thanks to a good old prism or even a raindrop, you can split sunlight into that beautiful rainbow. So far, so good. But here's the catch: not all colors travel the same way through our sky. Sunlight is made of waves, and each color has a different wavelength. Red light travels in long, lazy waves. Blue and violet light, much shorter and more energetic. This difference in size is crucial, because as light travels through our atmosphere, it bumps into those tiny particles we talked about earlier. And shorter wavelengths like blue are scattered in all directions much more easily than red. This is the essence of what scientists call Rayleigh scattering, named after British physicist Lord Rayleigh. This effect explains how tiny particles smaller than the wavelength of light scatter the light around them. Imagine a beam of sunlight hitting Earth's atmosphere. The red and yellow parts mostly shoot straight through, but the blue light, it gets ping-ponged around like crazy. That scattered blue light fills the sky, and that's what you see when you look up. Your eye collects that scattered blue light from every direction, so the whole dome of the sky looks painted in a gentle blue hue. But if blue light gets scattered so easily, why does the sky turn red during sunset? Great question. As the sun gets lower in the sky, its light has to pass through much more atmosphere to reach you. It's like driving through fog with your headlights on more distance. More scattering. By the time sunlight reaches your eyes at sunset, most of the blue and green light has already been scattered out. What remains? The longer wavelengths to red, orange, and gold. And that's what lights up the sky. So, sunsets aren't painted by the sun. They're carved by the atmosphere. Now hear us another mystery. Why can't we see stars during the day? It's not because they vanish. It's not even because the sun is too bright. The real reason: our atmosphere itself is glowing, literally. All that scattered blue light creates a kind of background glow that drowns out faint starlight. If Earth didn't have an atmosphere, the sky would look black all the time, and you'd see the stars twinkling around a blinding sun. That glow is beautiful, but it's also blinding. So where does our sky end and space begin? Technically, space starts where there's not enough atmosphere to scatter sunlight. By international convention, that boundary is about 100 kilometers up, or 62 miles. It's called the Kármán line. Above that point, there's not enough air to create a glowing blue sky. The stars become visible, even during the day. But Neil deGrasse Tyson proposes another idea. Instead of defining space by where the air ends, why not define it by where gravity lets you orbit? It's a reminder that space isn't just about air, it's about motion, mass, and momentum. Want a reality check? Our atmosphere, this big blue sky, is fragile. If Earth were the size of an apple, our atmosphere would be the skin. Maybe even thinner. Neil once held a globe and said, just a few millimeters up from the surface, that's space. And we're doing all kinds of damage to that tiny layer. Pollution, climate change, and deforestation, they all impact this fragile, life-giving shell. So, why is the sky blue? Because sunlight hits a sea of tiny particles, and blue gets bounced around like a cosmic ping-pong ball. It's physics, it's chemistry, It's beautiful. Underscore Neil said it best. The atmosphere is delicate as the skin of an apple, and it's the only one we've got. If you found this fascinating, hit like, subscribe, and share this with someone who still thinks the sky is blue just because.